Rachel, can you read us the essential question, please? Perfect. And then Henry, can you read us the I can statement? I can use the second derivative test to determine relative extrema. Okay, so remember relative and local mean the same thing. This is only going to work for relative. Most of the time when we do a problem, we're going to go to first derivative test and we're going to go to our sign chart where we're really comfortable. Okay. The reason I'm showing you this is what if they only give you the second derivative and you have to find relative extrema based on that? That's the reason we need the second derivative test. If you're given the original and you're asked to find relative extrema, you're going to do the first derivative test, use that nice little sign chart, and move on with life. Okay. But this is helpful based on the information because we don't know where they're going to start us on the AP test. Okay. All right. So I want you to take about, 2-3 minutes, maybe just 2 minutes. Read through that. Okay. Read through it a couple of times. See if you can understand it. If you see something that means positive, write a plus sign above it. If you see something that means negative, write a minus sign above it. Okay, hopefully you've gotten a chance to read it once, if not twice, okay? So in order for us to use the second derivative test, because remember when we talk about a theorem or one of these like important boxes, there's always what has to be present in order for it to work, right? Just like, when we're doing our theorems, it had to be continuous and differentiable, right, to have for mean value theorem to work. So what we need to have is we need to make sure we know where the first derivative is equal to 0. So this is saying we need our critical numbers. Need critical numbers. And then the other part is there has to be a second derivative that exists. Okay, we don't necessarily have to have it in front of us right there, but we need to know that, yeah, we can take the second derivative of it. Okay. All right. If our second derivative, what does this mean right here? Okay, what does greater than 0 mean? Positive. Good job, you guys. Like 15 years ago, there was some kind of standardized test that we had, and my students, we would get a question that was like x greater than 0. My students had no idea what that meant. I'm so glad that you guys can just look at that now and we can do it. All right, so if my second derivative is a positive number, I have a relative minimum. Okay, think about what that means. That if second derivative is positive, doesn't it mean that it's concave up? So if it's concave up, I better have a minimum, right? It should be down at the bottom. Okay. All right, what's less than 0 mean? Negative. So negative means we have a relative maximum. And if you don't remember which one is which, if you know the concavity, you can always draw the little picture, right? Okay, so set concave down looks like this. What kind of a picture did I get? Is it a max or a min? It's a max, okay? So I know that I might not have it memorized, okay? I might not just know it looking at it, but I know I could draw that. I know what a concave up and a concave down look like, and I know I could draw the little picture to help me out, okay? All right, so we're going to do this from an original function. Again, I'm showing you from the original all the way to the second derivative test. If we were given this on a test, I would probably just use first derivative test, okay? But there are times when we need the second derivative, so we need to just make sure we practice it. All right, in order to get to the second derivative, we have to do the first derivative, and we actually have to find our critical numbers from the first derivative. So there is a purpose for needing the first derivative to do the second derivative test. Okay, so let's find our first derivative. So what's the derivative of negative 3x to the fifth? Good. Okay, and then plus 15x squared. Excellent. I'll give you a minute to write that. Get it a little bit clearer there. Okay, our box there said that we had to find our critical numbers, right? That's what f prime of c equals 0 means. So I'm going to set that equal to 0. And I am going to try to figure out my critical numbers. Actually, why don't you take a minute? Try to find your critical numbers without me. See if you can figure out your critical numbers. You should be able to do that part. Think GCF. Okay, do you agree with as far as I got? Okay. I could do a difference of squares, or I could just do zero product property, right? So it doesn't matter, your choice. So I'm going to get into my zero product property. So negative 15x squared equals 0, and x squared minus 1 equals 0. All right, what am I going to do with this 15? What'd you do? Not yet. What am I going to do to get this to the other side? Divide it. What's 0 divided by negative 15? Thank goodness. I didn't want to take the square root of 15. All right, take the square root of both sides. What's the square root of 0? 0. So one of my critical numbers is 0. We're going to move this 1 to the other side. How do I move the 1 to the other side? Add it. Good. Okay, how do I undo the square? And what has to go in front? Good. So I should, whenever I have a squared, remember I should get two numbers. So plus or minus 1. So how many critical numbers did I get off of this? There's 3. Okay. All right. So instead of doing our sign chart, we're going to try finding our max and min by the second derivative test. So that means I need the second derivative. So let's get the second derivative next. So f double prime of x equals. All right, what's the derivative of negative 15x to the fourth? X cubed. Isn't it amazing how many times 15 times 4 comes up? Because you almost need to know, you almost have to have that one memorized. It comes up a lot. All right, 15 times, or 15x squared, what's that derivative? Good. All right, now we're not worried about setting it equal to 0, okay? What we're going to do now for the second derivative test is just plug these values into it, okay, and determine if I get a positive number or a negative number. So I'm going to find f double prime of 0. I'm going to find f double prime of negative 1, and I'm going to find f double prime of 1. Okay. So I put a 0 into this thing. So 60 0 cubed plus 30 times 0. What do I get when I put a 0 in? Good. All right, I'm going to let you put the negative 1 and the 1 in. You plug them in. I'm not going to worry about maxes and mins yet. Just do the plugging in part. You should be able to do that. All right, do we agree? One was 30, one was negative 30. Okay. All right, so let's go back and read that box and make sure we understand the box. Okay, and what we're given. All right, so it said if we had a positive number, we get a relative minimum. If we have a negative number, we get a relative maximum. All right, so is 30 a max or a min? 30 or the one that was 30 would be a relative min. Good. So relative min, and technically at x equals negative 1. Okay. Negative 30 is going to be what? Relative max, and technically at x equals 1. Okay, did you notice I skipped the first one? Did you see how this, it had to be strictly greater than or strictly less than 0? I cannot be equal to 0 in this work, okay? So when I'm equal to 0, it's what we call inconclusive. We don't know if it really is a max or a min. It might not be either. It might be a point of inflection, which we would have to do the sign chart to tell that part. Okay, we cannot get points of inflection off of the official second derivative test. Okay, you have to use our sign chart tests. So just so you can see why it's inconclusive, the graph is there. Look at, so we had the min was at -1, the max was at 1. Looking what was happening in 0, it was in fact a point of inflection on that graph. Okay, so it's still a critical number, it's just not a max or a min. So it's okay to get something inconclusive. Okay, it's not, we're not going to freak out if we see something inconclusive. All right, we have another one that we're going to work on, a little bit different because it's not an algebraic problem, it is a chart. So I am going to give you, I want you to read through the entire problem, all 4 parts, okay? So that you've read it all kind of once. I'm going to give you about 2 minutes to do that. So everybody's reading, just reading through example 2. About 30 more seconds to read through it. Okay, I'm going to read with you. All right. We're going to go through it again. I actually really like this problem for the fact that it doesn't happen very often, but sometimes they'll put these goofy zeros in a table on the AP test. And it's like, what the heck? Because normally we wouldn't see a table where we've got the goofy zeros in there. They're actually talking about the zeros where it's crossing the x-axis. Okay. I've seen it happen like one time on a free response question, and I know it confused kids. So All right, given the values of x for f, given the values below for x, f of x, f prime of x, along with the fact that f prime only has 2 zeros on the interval. So do you see the 2 zeros? There's a 0 here and a 0 here. Okay. And f double prime only has 2 zeros on the interval from -3 to 10. So that one also only has 2 zeros. Answer each of the following. They also give us a place where it's undefined, okay, on that first derivative, which could also be something critical going on there. Identify all x values where f has a relative minimum. Okay, so we're looking for a relative min. Justify using the first derivative test. Now, I didn't write this question, but the person who wrote this question is trying to mimic kind of the process of the AP exam. The AP exam is never going to tell you whether to use the first or second derivative test. You just have to kind of base it on what's there. So in this case, we're being forced to use the first derivative test. When I think first derivative test, I think sign chart. Okay. For me, I have a really hard time just looking at the numbers in the table and translating that to just being able to look at it from the numbers in the table. I always go back to my tried and true and I write out my sign chart, okay, based on the table. Okay. All right, so I am specifically looking at this row and I'm going to use my x values. Okay. And I'm going to try to convert this into what I know is my version of a sign chart. All right, so it looks like my interval starts at -3. My fences are where there are zeros. So where's my first fence? -1. Good. Okay. Where's my second fence? 3. And then it ends at 10, right? Okay. And we're just looking at first derivative. Technically, what's going on when it is less than -1? Do we have a positive or a negative? What kind of value? So when I'm between -3 and 1 there, what kind of number do I have? Is it a positive number or a negative number? Positive, good. All right, between 1 and 3, what kind of number? Do I have a positive or a negative? Negative, good. And then between 3, I know there's something undefined in there, but between 3 and 10, what kind of numbers are they? Positive. Even if I probably should have included the 7, right? Because that's technically I should have really included the 7 in there. It wouldn't matter. It wouldn't change my answer here because it's positive in both of those places. So it's positive, positive. All right. The question is asking us to find relative minimum. So we're not having to worry about increasing, decreasing. We just have to figure out the relative min. So what I do with that is I draw myself a little picture. I know it's going from positive to negative, and this one's going from negative to positive. So which x value has the minimum? Look at my pictures. Which one looks like a minimum? Yeah, 3. This looks like a relative min right here, right? Okay, so now we have to write the first derivative explanation for that. Okay, so we got to write it as a sentence. F has a relative min, and again, I am being really lazy in my abbreviations right there, at x equals 3 because f prime changes. How does f prime change? Say it louder. Good. F prime changes from negative to positive at this value if you wanted to complete the sentence. Give you a few more seconds to get that written. Okay, we are now going to identify where f has a relative maximum, but this time we're using which test? It says it wants us to use the second derivative test. So just imagine if I did not have the second row, it told me maybe where the zeros are, and they only gave me that, it doesn't have the third row. If they only gave me the fourth row, I wouldn't have a choice but to use the second derivative test. Okay. All right. I still am going to use those same zeros. Okay. So I am still looking at this, and technically that, those same critical numbers. Okay. All right. So I'm just going to look at what happens to them in the second derivative. So I need to know f double prime of this x value, -1. And then I need to know f double prime of 3 and f double prime of 7. Those were all my critical numbers from the first derivative. Okay, so what is f double prime of -1? What value? -1. Okay. What about 3? 2. Are we okay? We're looking at the right spot. Oh, were they covering the numbers? That happens, right? Sometimes you get a little happy about marking things up, and then all of a sudden a positive turns into a negative, or a negative turns into a positive. I do it too. All right, what about 7? What is it equal to? 0. So this one's inconclusive, right? Probably a point of inflection, maybe. We don't know because we don't have the picture. Okay. All right. We know that f prime of -1 is -1. So is that a maximum or a minimum when we have a negative? Good. So this is our max. And then what about 2? Is that a maximum or a minimum? Minimum. Okay, so we did not really write a good explanation on the last one. We're going to write a sentence this time, just like we would for the first derivative test. Okay. So f has a relative max at x equals -1, which is good that we didn't get the same answer as the first one, right? Because one was a min, one was a max. Okay. All right. Because f double prime of x is less than 0. You could have written is negative instead. Your choice. I'm going to erase some of my scribbles on here because it's kind of a mess, and we have to do another couple problems. All right, so part B was really the new stuff. A, C, and D are all old things. Okay, but it's always good to revisit these old things because they're very common on the AP test. So we might and the C and the A are going to be on the quiz tomorrow. All right, we need to figure out point of inflection. Where does point of inflection come from? Original, first derivative, second derivative. Okay, so let's review that. So first derivative, we get increasing, decreasing, relative max, relative min. Second derivative, that means we get concavity, point of inflection. Okay, you have to know those things. Okay. Have to understand that. All right, so what derivative am I going to look at for point of inflection? I'm going second. Okay, so I'm looking at my second, and since they gave us second derivative, we can base our explanation off of that. Okay, it isn't like we have to do the increasing, decreasing explanation because I only have first derivatives information. Okay, so I'm looking at this row. I'm also going to need these x values. Okay, I'm going to go to my sign chart because that's where my comfort zone is. Okay. So I know that's not what I wanted yet. I know that my intervals, notice my zeros are in slightly different spots. They're here and here. So I know I'm going from -3 to a fence of 1. I'm going to go to another fence of 7 and then end at 10. And then I'm going to look at my second derivative values. All right. What do we notice about all the values that are less than 1? What kind of numbers are they? Negative. Okay, good. All right, what about the numbers between 1 and 7? What kind of numbers? Positive. Good. And then bigger than 7, what kind of numbers? Positive. So where's the point of inflection? At 1. Okay. All right, so we're going to write a sentence for that. F has a point of inflection at x equals 1 because F double prime changes sign at this point. You could say it changes from negative to positive. That's fine. Okay. In second derivative, we just have to know there's a sign change. Max and min, it's a very specific direction. So you have to have the positive and negative in the correct order for that. All right. So we now need to do equation of a tangent line. What two things do we need for equation of a tangent line? Point and slope. Okay. Do you notice my shirt? It's point and slope. That was our shirt last year in calculus, was point and slope, because they did this in the chat like all the time last year. All right. So we have the x value. What is the y value? So if I'm going to go for my point, what's my y value at 5? What are we seeing in the chart? 3. Good. What's the slope at 5? 2. Yep. Nice. When you can look at that. How nice is that? We just got to read that out of the chart. All right. So y minus, what's the y value? 3 equals, what's the slope? 2. X minus what? We could do that all day long, couldn't we? Like, we should be getting close to the point where we see equation of a tangent line, we see a chart or a graph, and we're like, ooh, I love that problem. I know how to do that one. Okay. All right. That's it there. You do have a little bit of time left. We do have a quiz tomorrow. I'm guessing we haven't finished the review yet. So I'm going to give you the rest of the period to work on the review. Okay. I can't remember. Let me look for tomorrow. If we're going to start something or if I just have quiz on for tomorrow. I'm going to find it for tomorrow. It's going to be slow.